Hi, this is Jacek, and in this PHP security tutorial I'm going to be explaining SQL injection and also how to prevent it causing problems for your site. And we're going to be doing that using this example that I've got here. So before we get into anything to do with SQL injection, let's just quickly go through this example. So what we have is a very simple page that takes an email and password and checks to see if that password is correct. So essentially this is a login system, but without actually logging anybody in. It just tells you if you entered the right password. So it's using a database, which I've got phpMyAdmin open here with the database table open. And as you can see, we've just got this one user. So we've got the user ID as one, the user email address, which is quite important, and that's going to be used to identify which user is trying to log in. And then we've got the password, which is an encrypted string. So the way this works is, I'll just demonstrate. So if we type in the email address here, so admin@website, which was just the email address, and then say if we enter the incorrect password, the correct password is just password. Terrible password, by the way, another security tip, don't use password as your password. But if we just enter the incorrect password, so if I just type pickle, oh, okay, that should be a password field, but never mind. And if we just click login, you can see we get this incorrect password sort of printed out to the screen. And if we then enter the correct password, so if I enter the email address again and password as the password and hit login again, you can see this time you get access granted. So this is a very simple system. It's just telling you if you entered your password or not, essentially. So I'll just go over the code very briefly as well. So I've just got that open here. So generally this is sort of the process that you'd go through if you're sort of designing a login system. So you'd have, usually you do this with a function, but just for the purposes of this video I've decided just to do it all sort of in one file, just to keep it a little bit simpler. And the principle here is SQL injection, how to prevent it, not how to lay out your code. So to keep things simple, that's why. So what we're doing is, first thing we're doing is connecting to the database here. Well, this line is connecting to the database, and this other line is telling MySQL which database we want to work with. And after that, we're checking to see if the form has been submitted, and if it has, this block here will be executed. So we're defining a new variable called email, and this is equal to the email that the user enters. If I just scroll down to show you the form code, type text, you can see that we have an input for the email and an input for the password. So both of these are being sent using the form I just showed you. The password is being encrypted to an SHA-1 hash. If you're familiar with the MD5 hash, the MD5 function, instead of SHA-1 there, that's very similar. Essentially it does the same thing, except an SHA-1 hash is a bit longer, and it's sort of harder to guess, essentially, because of that. And then all we're doing then is using a very simple SQL statement. So what we're doing is select count user ID. So we're counting the number of rows in the users table where the user email is the one that they enter, so this variable here, which just comes from the form input, and the user password is equal to the encrypted password because we encrypted the password here. And then we're checking the number of, well, this is returning the number of rows, and then we're getting that result using the MySQL result function. Then just a little bit further down we have a simple if statement. So if is set total, because total will only be set, i.e. it'll only have a value if they have click the submit button. So if it's set, we check it against 0, and if it is 0, that means the password's wrong because the query has returned a count of 0, which means the email and password combination hasn't been found. And if not, we return access granted, or we output access granted. So that's basically how that works, and the problem is that we have sort of neglected to secure this against SQL injection, which means that anybody will be able to log in regardless of what password they enter. So if we just go back to our page, I'll briefly demonstrate this. So if we just reload this, and if we type in admin, so the email address, but then we put a single quote, a space, 2 dashes, and another space, then we can type anything at all, so that's not the password, hit login, you see we get access granted. So if this was a real login system, like to the admin area of your site, or well, anything that, you know, any login system shouldn't be able to just allow access to anybody, this would be like a very serious problem. So obviously need to do something about this. But first, let's just sort of go over why it's actually happening and why this works. Because if you understand that, then the solution makes more sense. So what we'll do is just go back to our code, and instead of actually, as well as actually running the query, let's just copy this whole SQL statement. Okay, copy this whole SQL statement, and then just above here, let's just do echo. We'll echo output the entire SQL statement. So then going back to our page, and if we log in properly again, so admin at website, and well, let's get the password wrong, and hit login, you can see, oh, there's a new line. That's a bit strange. Let's just view the page. Okay, yeah. Oh, it's because I made the HTML invalid. Anyway, so this bit here is the SQL statement that we're actually running. So you can see that our variables have been replaced with their actual values. So we've got select count user ID from users, where user email equals the email we enter, and the password equals this random looking string of numbers and letters. And this is actually an SHA-1 hash. It's the encrypted password. So because that's encrypted, well, okay, let's demonstrate the one that causes the problem first. So let's log in using the password and with 2 dashes, and let's get the password wrong again. So I'll just type anything and hit login. We get access granted, but our SQL statement has become this. So we've got select count user ID from users, where user email equals, and this is all the same, and then this bit here is the value that was entered in the variable. So it sort of looks like this is still because of this quote, but if you remember, we actually typed in this quote here. So this has actually modified our SQL statement and sort of changed its meaning. In MySQL, by the way, 2 dashes with a space following it means a comment. So this is essentially just ignoring this entire sort of end of the query. So all we're doing is actually checking where the user email equals this. So what we're actually doing is just checking to see if a user exists now, not if they've entered the password correctly. So you could type literally any password and it'd still allow you to log in. So that's the problem. And the solution to this problem is to escape the sort of any control characters. By control characters, I mean anything that has a meaning. So a single quote has meaning because it denotes the end or beginning of a string to the MySQL server. So to escape it, we just simply place a backward slash before it, and obviously we can't do that. We can't just expect the users to do that manually. So say if I just type it in again, if we replace this with a backward slash here and hit login, you can see that we get incorrect password, and we've got this backward slash here. And what the backward slash does is remove the meaning from the character. So MySQL will treat this whole thing, the backward slash and the character, as a literal, just, single quote. And that means that it won't contain its meaning, and MySQL will treat this whole thing as the string, instead of treating just this bit as the string, and then processing this as a comment, and dropping the rest of the query. So that's what we need to do. We need to do that sort of automatically. And luckily for us, PHP has a function that does this, and that function is the MySQL real escape string function, like so. If we just save this file and go back to our page now, if I log in, if I just log in with the sort of exploit, if you like, and the password can just be try, why not, and hit login, you can see that this backward slash has been added automatically and we get incorrect password. So this has prevented us from performing the SQL injection attack. There is, however, another problem, and that is that, it doesn't necessarily open up security problems, but it will sort of cause problems. It'll make some of your output look a bit weird, and it may make users not able to log in that should be able to log in. And that problem is magic quotes, which is a feature of PHP that has been removed in the newest version. or well, will be removed in the newest version, and it essentially does this escaping automatically for you without you having to call the MySQL real escape string function. And the problem with that is that if you have that turned on, enabled on your server, and then you apply MySQL real escape string, you get double escaping. So what actually happens is you'll see 3 backward slashes here, because a backward slash is a control character, so that is escaped as well as the single quote. It's quite awkward, but well, it looks a big mess basically. So then what you would actually be checking is admin backslash as your username, which would obviously not work. So the solution to that is to first check in your code if the if magic quotes is on, and we can do that because PHP provides a function to check if it's on. So what we would do is just here we would do if get magic quotes GPC, which just returns 1 if magic quotes is on. So we can just use it in an if statement like that. So if it's on, we need to undo the effects of magic quotes, which is done by using the strip slashes function. So we can just do post email equals strip slashes post email, like so, and that will remove the effects of magic quotes. Although doing this for every input is a little bit awkward, so another sort of useful tip is to do this in a function. So say like somewhere in your back end of your site you defined a function like this. So if you had a function called, for example, mres, so just MySQL real escape string but sort of shorter, and you gave it one parameter which was input, you could have this function do the check. So you could just have if get magic quotes GPC. So if it's on, remove the automatic escaping from the input variable using strip slashes on input. Is that right? Looks right. And then after that we're sort of at the same point, if you like, whether or not magic quotes is on, because it's been removed or it just hasn't been applied, and then we can just return MySQL real escape string of the input, obviously, and we don't need a capital S. So what that will do is always return the sort of escaped once result, and then obviously to use it you just replace, we don't need this anymore because we're doing that in the function, and here you just do mres, like so. The MySQL real escape string function, by the way, does require a connection to the MySQL server because it checks the character set and does some other complicated things that you don't really need to think about. But before you use the function, just make sure you are connected to MySQL. So we can just test this, make sure it does actually work. So let's go back to our page and just click login, and apparently it has worked because I've got incorrect password. But let's just check by doing the SQL injection again. G, and you see we get incorrect password and the single quote has been escaped. Now there is another problem, and that is numbers. Say just for example, if you wanted the user to enter their ID instead of the password, the query instead of this would be where user ID, because that was the name of the column, equals, and just for the sake of sort of simplicity we'll use, oh no, let's change it. Let's change these variables to ID then. I was going to leave them, but it seemed a bit too lazy. And ID, scroll down, and name ID. There we go. So now, if we just go back to our page and hit reload, oh, obviously, sorry. Let's just change the actual outputted query as well by just copying and pasting that whole line again. And if we reload the page now and try to log in with, say, 1, which was my user ID, and the password of pickle, Login on line 12. Good. Oh, right. Oh, that was a little stupid. Sorry. Right. I'm apologising. Okay, so now we've fixed that stupid mistake. Let's hit resend. And now you see we get incorrect password, although that's still in quotes. Numbers don't need to be in quotes, which is actually the point of this little add-on section. And also that should be user ID there. Okay. I'm not sure when that changed. Maybe I copied and pasted the wrong one. I think I did, didn't I? Okay. Right. Okay. Back to being professional. So resend. There we go. So select account from users where user ID equals 1 and user password equals the password. Now the problem here is that without the quotes around it, you can enter sort of control characters and they won't be escaped. Well, not necessarily control characters. Well, anyway, let's just do the example. So say we entered 1 as the ID and then a double dash with a space after it and then any password and hit login. You see we get access granted. And if you notice that our actual input here, none of it has been escaped because these dashes aren't considered control characters and they're not escaped. So again, this has just dropped this whole part of the query. The reason this has happened is because we're able to still influence the query, if you like, by what we're doing. We are sort of, our code is assuming that we've entered a number, just a number, and we're actually entering a string instead, and that is sort of placed into the query. And the solution to this is again quite simple, really. There's a sort of method you can do to, well, let's just demonstrate. If we go back to our code, instead of just mres, what you can do is replace that. So remove the function and instead cast the variable to an integer. And what that will do is drop any character after the first non-numeric character. So regardless of what they enter, only the sort of first number part will be used. So going back to our code again, hitting reload, hit resend, you can see that the double dash has disappeared even though we entered it. So that is essentially it for SQL injection. So the bottom line, to sum up, if you like, if you're using a string and you have quotes around it in your actual SQL statements, you need to apply the MySQL real escape string function. If you're using a number and it doesn't have quotes around it, you need to cast it to an integer, which will drop, like I said, it'll drop any non-numeric character. Okay, so hopefully this has been fairly useful, and thank you for watching.